Hello and welcome to the third of the Scripting for Beginners tutorials. Hi, my name's Andy and I am going to be running this tutorial, this workshop, this stream for the next couple of hours. We're going to be diving into Crayta and doing a little bit more scripting. We're going to be exploring Lua. We're going to be looking at the Crayta API in a bit more depth. And most importantly of all, we're going to be thinking about what it means to be a programmer and how to think like a programmer and how to break down problems and all of that stuff. The rest, you know, all the syntax and the writing, the code and things like that will come with practice. But that's what this is really about, is kind of, how do we make games using Crayta, using Lua, and getting all of that in your head. So shout out to the people who are already here. Hi guys. Hi everyone. How's it going? Hi Mariam. Hi Hofnuglin Gaming. Hofnung Slickline. Cool. Lovely name. Hi Highskin. Hi everyone. Good to see you all. Thank you for joining me. If you don't know what this is about and this is the first time you're watching me do a bit of scripting for beginners, it's actually the third sort of episode in a mini series that I've been doing, looking at day one basics. This is how you get into scripting in your game in Crayta. And then bit by bit, we're piecing together what all of the different concepts are when it comes to scripts and when it comes to writing code. And generally speaking, a lot of the concepts that we talk about are fundamental for programming in any language. But more importantly, these are things that we're looking at in the context of Crayta with the Lua API that Crayta has. So yeah, I think it's a useful thing for everyone. Hi, Zian Siton. Hi, how's it going? Thanks for joining. It's great. I've got a tiny coffee, which I'm going to drink. It's so tiny. It's lovely. Okay, so what did we do last time? Let me catch you up to speed. Going back over what you did either the day before or last session or whatever is a really good way to strengthen those neural pathways. So let's do some of that strengthening. What do we do? You can write in the chat if you just call me Zion. Okay, will do. You can write in the chat if you remember. If you have any questions that came out of last session, feel free to throw them in there. Hello to all the people from the Discord as well. There's usually a bunch of people from Discord who come and watch and generally participate in helping people, solving problems, answering questions. If you aren't a member of our Discord community and you are struggling with programming, then I would recommend that as a good place to go to get help with your programming issues or problems, or just getting some feedback on your code, all of that stuff. So discord.gg/Crayta. That's where our Discord's at. And you can go there. It's a really, really lovely community. Everyone wants to help each other and make awesome games. And it's great. Go and hang out there for a bit if you like. Okay, so back to where we were. We were talking about recapping on what we did last week. It was so long ago. So I've got my notes in front of me. So the first thing we looked at was we talked about opening a door, didn't we? We said, let's make it so that we can interact with this switch pedestal. And rather than the switch pedestal exploding, which is what we did in week one, we said, let's interact with that and make this door open. And that was an interesting thing because we looked at events. So we wrote this door script. And originally the door script was on the pedestal, wasn't it? And we said when we interact with the pedestal, we use the onInteract function, and then we tell the door to disappear. And we had a property for the door, and we made it invisible. And then we were like, maybe there's a better way to do this. Because if we left it so that there was a script on that pedestal, and it made the door invisible. One, doors don't just turn invisible. It looks a bit silly. These doors open, which is frankly more accurate in my experience of doors. I don't know any doors like this one, but in the general scheme of doorness, I'm assuming a door will open. So firstly, making the door open using animation. And then secondly, it was also like, well, what if we wanted something else to open? What if we wanted this cage to be able to open? And then any other doors in my games, do I want to program separate scripts every time to make specific doors open? Do I want to put the script on the door handle to open the door, or should the door know how to open and close? And we got into all of this stuff about where do you put scripts and why and all of that sort of stuff. So, and in the meantime, we kind of mentioned it was an entity component system, an ECS. So if you haven't heard of an entity component system, that might have been new for you as well. And what that means is just a way of us thinking about and kind of being an architecture for our code, being an architect for our code. So not just thinking this single script here and this single script here and having everything all over the place. It was thinking about all of the code in our game a little bit more holistically and what structure that's going to have. And there's loads of different ways of doing that. That's totally cool. You can go anywhere with that. But the way we were looking at it was at this entity component system approach, which means we have entities in our game and those entities can have components. Those components are scripts. You can kind of use the terms interchangeably in Crayta in this context, because a component is a script in Crayta. So each entity, let me turn that sound off. Go away. So each entity can have multiple components, and that was like a really important thing. So we were like, right, so maybe instead of just having scripts everywhere and not knowing where anything is or how it works, maybe we think about this a little bit grander. We're going to write a door script, and it can go on any door, and it means that we'll be able to open that door using animations and sounds and effects and things like that. So we changed it from a script on this pedestal, which could open this door by way of reference, and instead we wrote a door script that we put on the door, and it meant that we could open it using this pedestal by hooking up our onInteract event here and then running a specific function on that door, so that when a player interacts with the switch here, it will talk to that door and it will fire, it will run, it will execute, even better word than run, it will execute the open door function on the door script, which is attached to the temple door. And by doing it this way, it means that the door has these components. It's got a door component attached to it, so it can open and close and things like that. And so that's a thing to get your head around. Is, you know, there's lots of different ways of like managing all of your scripts, and that was our first look at one of those possible ways. We did that, and then we started to think, okay, let's make this a little bit more interesting. So we added some sounds and all of that kind of stuff, and we looked at how we can have properties like this, which are these are possible things that this script knows. So these properties are things like, okay, a door opening sound, and we can put a sound asset from our sound library in that property, and when we run the game, that sound is stored in that property, and we can refer to it while the game is running in our code by referring to that property like this. And so we added some sounds to the game, and then we played them using getEntity play sound like this, and that worked. And then we looked at, okay, this function here with play sound returns a reference to that playing sound, and we can store that. So we have a sound which is in our sound library, and that's like a sound asset. And then we also have when the game is running, we have a sound that can be playing in our game. And that's different from the sound asset. We've got assets that sit in our library and we can use them in the editor to build our game world. But when the game is running, something like a sound doesn't technically exist until it's being played, and then it exists in memory as a sound that's being played. And you have two different types of sound. You've got a type of sound which is like a one shot, so it just plays start to finish and that's it, done. And we also have looping sounds, which means that it plays from the start to the end and then starts again from the beginning, and it will do that forever while the game is running. Not forever, like, let's be reasonable. While the game is running, it will do that. And the sound we chose to play for our door opening sound was a looping sound. It was the sound of a boulder rumbling. And so we grabbed a reference to that, and then we waited for a bit and we stopped it. So because it was a looping sound, it would go on continuously even once the doors were opened. And so we looked at how we might stop that. We used this stop sound and we passed a reference to the playing sound like that. We also, at the same time, this was a very complicated part of last week because we also introduced this idea of schedules. And a schedule is where we take our code, which runs like this, do that, then do that, and blah, 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 in order. And we kind of expanded it a little bit. We broke out of that a little bit because normally code goes this, then this, then this, then this, and it just goes through it line by line, executing in order. If you use a schedule, imagine you're starting another list. And so this one will keep going past that schedule. So it will keep going down here. And the schedule breaks out into a new step by step. So then you have two things going step by step, and they might work at different times. And that process of breaking out into a separate thing, of using schedules to break out into a slightly different timing, that's called asynchronous, where no longer is it step by step by step, it's now in multiple threads. So we have this schedule function which breaks out, and it's basically anything after this function until this end here will run in its own step-by-step order, and meanwhile the rest of the code carries on down here. The reason we were doing that was because we wanted to be able to wait for a couple of seconds, and normally code runs on the main thread, so code normally runs on the same sort of thing, on the same cycle that all of the other stuff is running. And so by breaking it out, so if we were going to wait for a second, we would freeze the whole game. We'd go, hey, stop, let's wait for the doors to open and then stop the sound and then carry on. And what we don't want to do that. We want other things to be able to happen. We want players to be able to run around. We might want, I don't know, damage to occur and all that sort of stuff. So you can't actually use this wait command unless you're using a schedule. So you have to use a schedule first in order to use wait, and then you pass the number of seconds you want to wait before you use the next line of code. And this is really, really important, really, really useful to time things. So if you do anything in your game to do with timing, if you do anything in your game to do with UI and things like that, then this self-schedule with wait commands means that you can hold on a second in one part of your code and carry on in other parts of your code. Managing those then joining back up can be very tricky, and you end up with things called race conditions and all sorts of stuff. But what's really fun is being able to stop a sound when the doors are fully open, and even play door impact sounds when the doors are fully open. So there was a few concepts last week, and I'm just going back over those, and you might remember some of them. You might have dipped in and out, and so maybe this recap is kind of helpful in that scenario. If you have any questions about schedules and waiting for code and stuff, now's a good time to ask. I'm just going to take a sip. Okay. Ask away in the chat, and I will respond however I can and see what may lay there. Okay, so we did playing sounds, we did stopping sounds after a certain amount of time, and we sort of talked about how we can do a lot with play animation, play sound, hooking up events with each other. So, you know, grabbing our pedestal and hooking that up to the door, a function on the door. We can do a lot with just this quite simple stuff and add a lot of effects to our game and make it fun and juicy and all the rest of it. But there might come a point where you want to start coding a little bit more gameplay type thing. And that is where we might start to use conditionals. And in this scenario, in this game, we added a lever, and we said this door is locked and we can't open it even by pressing the switch pedestal. To unlock it, you have to pull this lever, and then you can press the switch pedestal to open the doors. And there's a few different ways of doing this. Some are easier than others, but we were looking for a way that would be using conditionals. And so we looked at this lever and we added a script to the lever that handled all of the lever animations. So we don't have to worry about that. When you interact with it, it did its thing and all the rest of it. Interestingly, this lever script would also work on a whole bunch of other things, because the activate and deactivate animations are like standard amongst a lot of animated props in Crayta. A lot of animated meshes use the same animation names. So we had a lever and we wrote a script that kind of handled all of the animations of the lever, and then we also hooked the same onInteract function. So we had the onInteract function, which handled all of the animations, talking to the lever itself. And we also talked to the door, and we said, execute the unlock door function, which is this one here. And this just flip-flops, or this just literally turns the locked property to false. And the lock property is a Boolean, which means it can be either true or false. You can either have a door that's locked or not locked. It can't be halfway locked. You know, it might catch or whatever, get stuck. I don't know, but then it's technically locked, right? So we have this locked property, and we have a lever that is hooked up to the door, the door script, and it just says unlock the door, and all that does is turn locked to false. So when we interact with the lever, the door unlocks, and when the door is unlocked, and then we used conditionals, didn't we? We said, if the door is locked and you try to open it, just play a locked door sound, generic locked door sound. Otherwise, so if it's locked, play the locked door sound. Otherwise, it's not locked. So it should be able to open. And that's when we said, okay, if it's not locked, then it's unlocked. So we have if, then, else, end. If some expression, then code to execute when that expression is true. Else, we know that expression is not true. So we know that expression is false. Run some code to here's some code between the else and the end that should execute when that expression is false. So we've got if, then, else, and end. And these are keywords that you see in Lua. And you also see them in lots of other languages. Sometimes the then is replaced with other syntax. But this conditional, this is what this bit's called, a conditional, is like a key fundamental programming concept that exists in loads of stuff. And so by learning it, you're learning how to make some cool, awesome stuff and great games in Crayta with loads of additional functionality. And you're also learning some sweet programming skills. So that's pretty cool. Would the lever script work for use on a key to unlock a door? Yeah. So you're thinking, that's a great question, by the way. Sakwiri Seton Daniti. Great question. Could this be a key rather than a lever? And it absolutely could be. So you could do something like when you activate the lever, if we were to, let's just have a look at this as an idea. And I love it because it's such a good idea. And it makes so much sense. If we change the lever mesh asset, so at the moment it's the lever mesh asset, and we can change this into anything like a lemon or whatever. We can change this to be a key, JKL, so JK. I mean, I could search, but where's the fun in that, right? Key. Big old golden key. There we go. Delete it. Yeah, good question. Let's just rotate it, because why not? And I'd probably add like a light so that it's pretty obvious that, or maybe an effect. Sparkles. Let's add some sparkles. Okay. Yeah. I mean, that looks very collectible, doesn't it? Getting into game design. Stop it, Andy. Okay. So we have a key, and basically, if we now run the game, this key, it might cause some problems because the lever's animated and the key's not. If we go up to the key and interact with it, we heard the sound of unlocking. And then if we go to the pedestal, it opened the door. Right? So maybe what we do here is rather than that sound of unlocking, which is this bit, we could also just do self get entity dot visible is false, and then change the activate sound to be something more like we've picked something up. Let's have a quick look. Yeah, generic pickup, fine. I mean, this code here where we've got our play animation, let's just not have that for now. Because this key isn't animated, so none of that would make sense. So we're only changing little bits. We're just making the key invisible, and we're just removing the animations from this. Let's try that now. The sparkles will probably stay there, but never mind. Okay, so picked up the key. Another way we could do this would be, and let's finish it. Let's go here. Does this work now? Yep. So another thing we could do is we could just destroy the key, and that should destroy any children, like the sparkles we have is a child of that key. So now it should feel like way more like we're picking the key up. Let's try that. So got the key over here, pick it up. No sound. Interesting. Maybe because we destroyed it, the sound didn't work. So we've picked up the key, and now we go to the pedestal, and the pedestal works. So, you know, you're only tweaking little bits here and there. It might have been better to almost like turn off the effect, or not even have the effect. Turn off the key visibility, set the key to be active. I guess that's because we were using our lever originally, but it's mostly set the key to be invisible, and we also had the key hooked up to the door, didn't we? So no, that this our lever script function here, activate, all we're doing in that now is just setting the key to be invisible, which makes it feel like you've picked it up. But the other thing is, when we've picked it up, we're running the unlock door function on the door script. So super great question. Loved it, because now we can almost pick up this key, and then we could just interact with the door or something and then open the door. And you've got like a slightly different puzzle then, just through some small tweaks. So let's return it to the lever, and hopefully that answers your question. But yeah, good question. And what's really cool about that question is it shows that you have some pretty sweet understanding of what's going on. I've now made it so the lever disappears. Whoops, don't make it disappear. Don't do that. I'm just returning it back to how it was. So let's go to the lever. Okay, so the lever plays an animation, plays a sound. Let's go to this plinth, and the plinth now runs the open doors animation with an impact sound, and the impact sound was just a note. I don't know if you noticed, but compared to last week, hey, we've got something in here now. This is some kind of tomb situation that we're going to use as for today. Just check that I've done everything that we needed to talk about. Yeah, we had conditionals and we had schedules, and they were kind of our big meaty bits, as well as a few API calls and to play animations and sounds. And that brings me nicely onto what we're going to look at today. So today, and I know that it's been a half an hour recap, but I think that recapping is super important when we're doing our first foray into scripting. So and you can skip past that if you're watching this on YouTube at a later date. You could just where's the good stuff, right? So today, what are we going to do? Well, I think that the next thing we need to approach in our games development especially in scripting, is the idea of what do you do when you've got collections of things. It's all very well and good having one thing here, one thing there, a key, a lever, a single plinth. What happens though when I want to play lots of sounds or turn on lots of lights? How do we approach that situation? What happens if I want to turn on lights one by one? And this kind of scripting, again, it's not necessarily we're not going to look at it in the like very fundamental game mechanics part. We're more looking at it as like, well, let's see what we can do with this to start with, and then we'll start approaching the game itself, which is hiding under here. It's an obstacle course down there, and we'll look at how we can tweak and change that to make more gamey stuff. We're focusing on scripting in this series, so that's what we're looking at today. We will be doing how to turn on and off a light to start with, and then we will add a few lights and look at how we turn those on and off all together, and then we will look at maybe doing using schedules to make a flame with a flickering light. I thought we could look at something like that, and then hook that up to when the door opens, so that it feels like this is like a moody cave type thing. So to start with, to make this world feel a little bit more like we actually, hey Andy, mehwell aquemo, hello, nice to see you. Elbow golf. Yeah, I do that. Right. Yeah. So what was I going to say? Where was I? Yeah, to make the world feel like it needs light. Let's fundamentally change it by going in here to our world tab, and we're just going to increase this here. That feels cool. Can we make it that dark? Okay, so it feels quite dark. Let's see what that's like now. What I'm trying to do is just make it so that our world, we can still see what's going on, but it would be a lot easier if we had lights. So you can do it on hard mode where you basically can't see anything. And we can open that and then go in here. Yeah, and it would be so cool. It would add so much to this world, because we'd be able to see things if we had some lights in here. So that's what we're going to look at. Let's add some lights. And when I'm working in the editor and it's dark like this, it can be quite tricky. So sometimes you can click this editor rendering settings override. And what this means is that in edit mode, all of the lighting and all of that stuff is just ignored, and it's just basic. It goes to the default sort of thing. And so when we're working on it, it's light, and then if I test the game, it goes back to dark. So there's like a little bit of a tricky thing where you have to think about what it's going to be like in the game, or turn that button on and off. But yeah, let's start with that. Let's add some lights to our game world. So you can get these cool tiki torches and that would feel in keeping with my theme. So let's add one here, and let's add a little candle flicker to the top of it. So using the effect, fire candle, plonk that on there. So we've got this little light. I'm just going to very slightly adjust this because the precision adds a lot to this, the look of this. Let's just uncheck this and see where we're at. When I haven't got the effect selected, it isn't playing. And to keep it playing, I can check the simulate box, and now it'll keep going. So that looks pretty cool. It looks legit. Maybe I can now add a light, because although this little flame here is like bubbling away like a candle, it's not actually lighting anything. There's no effect on the environment. The light you're seeing is all coming from the light, light from the sun and the ambient light that exists in the game, just everywhere to lighten things up. So we still need to add a light to this. And if I click on primitives and click on light and then add a light just there, in fact, I'll put it on the actual candle and then center it 0, 0, 0. And so now it's right in the middle of there, and you can see immediately what this does is it lights up the area around it, and as you go further away from the light, it gets darker, just like a real light. Light is very rarely white, so let's make it more like it should be, like an ambient thing, and let's really calm it down. It is a candle after all. Exponent's an interesting one, right? Because it sharpens up the shadow the lower the number you go. I tend to leave things fairly high like that, but it's up to you. I'm not going to turn on shadows. You could turn on shadows. Shadows is something to use really sparingly because it adds a lot of performance overhead. And so the more shadowy lights you have, the closer you're getting to the GPU and frame rate and all of that sort of stuff. You really need to start managing all of that carefully. So just be a bit aware if you start playing with lights and shadows, and particularly making your lights dynamic and crossing over each other. So having multiple lights causing shadows near each other, that takes a lot for your GPU to figure out what's going on there. So yeah, just bear that in mind when you're playing around with lights. The attenuation is how far away from the light will spread. So if you're looking for like a really close, tight light, you might go a low attenuation, but like really drop the exponent. Because this is a candle, I'm going to keep things fairly soft. And because I also need it for gameplay to actually see what's going on, I'm going to make it a bit brighter than a normal candle would be. It probably wouldn't be bright enough to light this amount of area, but I'm just going to do that. And there we go. Oh, that's Tumbak. Hey, Tumbak. Yeah, the light on and off will work for your house. Fantastic. Good opportunity. Right, so we've got this light, and now the light is making some light in the scene. Yeah, so that works. The sunset's quite vibrantly red, which is pretty cool, and it adds a lot of drama. So I'm okay with that. I'm not changing that. It's fine. Anyway, where were we? What we were going to do was take this light we now have, and we're going to add some code to it so that we can essentially turn it on. Now because we've been through exactly how to do this sort of thing already, essentially turning things on or off, you might be able to run ahead and experiment, try it out, see if you can figure this bit out. How are you going to make sure that this light feels like it's turned on when you interact with it? Another thing I think we might need is sound, but we'll do that in our script. We'll play the sound in our script rather than putting it in the game world and then turning it on. So there's a couple of options there. You can either add it to your light and then have a reference to that in the script and turn it on or off when you're turning your light on or off, or you could play the sound like we have done before. It's up to you. You can choose. The reason I'm adding the effect in the game world rather than playing that through the script is because it gives me an opportunity to position it exactly where I want to without then having to put those numbers into code somewhere and worry about all of that stuff. But if you notice, I can click active and inactive, and that will actually play the start and end parts to this effect. So it's worth bearing in mind there's different things you can do here. Like rather than doing visible, which just turns it on or off, he said, turns it on or off, active, you can actually see the animation of it lighting and then getting snuffed out. Whereas visible, off, on is very, you can see, you know what you're doing. Cool. So what we're going to do is we're going to write a little light script. Add script, new script. So I've got my, it's a good job I did that because I've actually got my effect selected there, and I don't want it to be the effect that I put the script on or the light. I want it to be the tiki torch. So I'm going to in entity add script, new script, and I'm going to call this light script. The reason I'm not putting it on the light itself and instead I'm putting it on the torch is because whilst it's called light script and it's really concerned with turning this light on, it's also going to play around with this effect. It's also going to add a sound. And so I'm putting it on the root kind of unit, the root entity for everything under which is going to need shifting, changing, and playing around. Hopefully that makes sense. Let's go in our light script and let's now get rid of this example property. And what we want to do is we want to probably write ourselves a little function that will turn the light on. And so that function needs to refer to this light. So we need a reference to the light to turn that light on. Refer to this effect. So we need a reference to the effect to turn the effect on. And play a sound. So we need a sound asset to play that sound. So let's add some properties. Name equals light. Type equals entity. And we can do some super cool work here where we go is equals light. And that means this property is called light. Its type is an entity, and an entity is anything in my game world. Could be sound, could be a mesh, could be a voxel mesh, could be a player, whatever. They're all types of entities. And then we're going is equal to a light. We're specifying a specific type of entity. We're saying it can only be the light type of entity. And so that's how we specify a specific type. So if I now, you can see there's an asterisk, which means I haven't saved it yet. So if I now save that, and let's go and have a look at the script, you can see I have a new property called light, and it will only accept a light in here. And so if I try and drag on, let's say the candle, it doesn't like it. If I drag on the light, hey presto, it works. So we now have a reference to our light. What else did I say we needed? We needed a reference to our effect. So flame effect. Type is entity. And is equals effect. I wonder if that works. Yeah, there you go. So now I need the flame. There we go. That's that one. And the last one was name equals fire sound. Type of sound asset. And so that will be the sound we hear when our light starts playing, our little candle starts playing. So I wonder if there's a candle sound. Hey! Oh, that's the effect. I wonder if there's a candle sound. Hey, there's 3. Yeah. There you go. So we have a light, we have an effect, and we have a sound. And now we need some functions to execute. And one function will be to turn it on, and one function, well, that's all we need for now. We could write ourselves a little function to turn it off if we wanted to as well, just in case we might need that in the future. But for now, let's just write a function to turn this light on. Function light script. So if you're not sure what a function was, or you've forgotten since last week, a function is essentially a small block of code. And in that block of code, it can have a whole range of different instructions. But the main thing is it can be executed. It can be called from somewhere else in the code. There are special functions which are called by the Crayta API, and those special functions are called entry points. And you can find those if we open up our Google Chrome, api.crayta.com. You can find, scroll down to script, and you can find all the entry points here in this section. And so these are all special functions, and they will be called automatically by Crayta. And so they all run on particular events. For example, on jump. If a script is attached to a player, on jump will be called when that player jumps. So things like that. But we're going to write our own special function that we will call ourselves. So let's write that. So we've got function light script. So the name of the script first. We see that here. And is light case sensitive? It's a good question, Sinjin. I will check it out in a sec. Function light script colon a light. I think a light doesn't mean what I think it means there. Let's just put turn on. I think a light means leave the train or something. A light here to change to another train. Pretty sure it doesn't mean burst into flames. Just kick that for sure. Okay, so let's turn on the light. You're going to run this turn on function. And so in here, we're going to firstly make this light visible. So light, that light, what have we got? What properties can we change in here? We can change any of these properties in our code. So we can change things like visible, we can change the intensity and the exponent and all of that stuff, but we're just going to make it visible. So it's going to start invisible, and when we light it, we're going to turn it visible. So let's leave that visible box unchecked, and we're going to do self.properties.light.visible equals true. So really similar to the stuff we've done before, right? For the effect, which is this one here, we need to, we're going to leave it visible, but we're going to make it active, because then it had this candle sound is still going, because then it had the sweet little lighting animation. So we'll do self.properties, and what's the name of our effect? It's up here in our properties bag. Self.properties.flameEffect.active, not visible, active equals true. So when we turn something from not active, so active is false, to active is true, it will start with that animation. And finally, fire sound. We need to play that. And we actually have that kind of code already. So if we were feeling lazy, we could just go over here to our lever script where we already have this, copy that and paste it in there. Self, get entity, play sound. So get hold of whatever, self refers to this script, get entity refers to whatever entity this script is attached to, and play sound is a function that Crayta supports. Let's go and have a look at that function in entity, play sound here. So play sound is a function that exists already, and all it means is that Crayta will play a sound, and we have to give it a sound asset between the two brackets, and it will play whatever sound asset that is. That will do for now. So turn the light on, make the flame active, and play the little candle sound on this entity. Should we try that out? So I'm going to press, there's no point in trying that out, because why? Maybe you can answer. Because this function doesn't get called yet. It's not executing. It's because we called it our own thing. So it means we have to decide when to call it. Crayta doesn't know when to call turn on the light script. So I'm going to add a binding to onInteract to execute this function. So I'm going to click the plus on onInteract. I'm going to drag the entity which has, I've done it on there. Whoops. I accidentally did it on the effect. And so I don't want that. So I'm going to right click and delete binding. The mesh that I want to use, this tiki torch, that's what I want to be able to interact with, because I can interact with a mesh. So on interact, I need the entity which has the light script attached to it. So that's this torch tiki one. Put that on there. It will automatically choose the light script because that's the only script on here. If I had loads of scripts on here, this would be blank and I would have to select it using this drop down. And the event is the function that I want to call when the player interacts with the light mesh. And so that's the only one that's in the light script, which is turn on. So that's hooked up. So let's try that out now. Cool. There's some good questions coming in. I have got my effect. My effect was already on. So let's deactivate that effect. There we go. Right. So effect is not active. Light is not visible. Let's walk up to this and then interact with it. Hey, it's now visible and the light's now visible. The effect has started and can I hear the sound? Play sound called with no sound. That would be because I copied this line of code and I didn't change the sound. Our sound is called fire sound. So we need to change that. And there's some great questions and I'm going to answer them in a sec. But I'm just finishing this chunk and then we will do that. So go up here. Boom. And now I can hear the sound. Cool. So some great questions. First one was, is light case sensitive? Let's take a look. So this light here, which is the name of the property. So remember we have these names of our properties. That light, it doesn't matter whether it starts with a capital L or a lowercase l, as long as you use exactly the same here where we use it. So if I wanted to, this could have a capital L, and then I would have to make sure that wherever I'm using it would also have to have a capital L. Reason we don't use a capital L is just convention in Crayta. Different languages have different conventions, and actually you can make up your own conventions, whatever works for you. Some people have, letters and stuff to say what type of entity it might be, or what type of asset it is, or what type of data is coming in. You can use whatever naming scheme you feel most comfortable with. I'm using as descriptive names as possible because the purpose of this is to talk about scripting. But hopefully that makes sense. Is equals light. Now, last week I hit a snag because I started using capital S and capital A for sound asset, and that is not accepted. So it has to be all lowercase if it's the type. If it's in the is, let's find out. Lowercase l works. Let's try uppercase L. Oh, it's just removed it from this properties over here. So lowercase l, let's put that back in, save it, and let's actually try uppercase L and then drag the light in. Okay, that looks like it works. Let's try running it. Proof is in the pudding. Yeah, looks like uppercase L works, but it works on the is equals thing. It doesn't work on the type equals thing. So the type has to be all lowercase. The is, which is the kind of the subtype, I guess, of the entity, it doesn't matter. But I would generally, because this is all lowercase in the type, I would generally go for all lowercase there. Good question, Sinjin. Okay. One on interact function to turn on and to turn off, or would have to be two separate functions? Great question. You could do either. You could do turn on and turn off, and then just turn these to false and stop playing the sound. You would need to take a reference to that sound with you to the turn off. Another option would be, and something that's usually worth doing, so would be instead of turn on and turn off being separate functions, you could do a toggle function like this and then use conditionals. So we can do something like light script init end here, and we can do conditionals. So we can do something cool where we say self, we add a property in here. which is flame on. And the boolean, it'll be a boolean, and all it's doing is storing whether the flame is currently on or not, whether the light is on or not, right? And if I save that and look at this script, I now have this little checkbox, flame on or not. And if you wanted to, you could leave it so that you can turn this on or off by default, and then make it so the player can turn it on or off when they interact with it. Or you can hide it by going editable equals false in here. And now it disappears from the properties, but I can still reference it in my script and change it in my script. I just can't in the editor. So that's a handy thing if you're ever writing packages as well. If you're writing code that you want to share, that can be handy to help people from not turning things off that will break it, for example. I'll leave it on. I'll leave it available to us for us to change in the editor. So we can decide whether we want the fire on or off to start with. Now, instead of the turn on, we're going to have toggle. I'm going to get rid of this in it. No, I'm not. We can have toggle, and in our toggle, we will do if self.properties.flameOn, then else end. So there's that if then else thing again. And so if our flame is on, then we want to turn it off. And otherwise, our flame must be off, so we want to turn it on. So we would copy this code and put it in here. At this point, we know the flame is not on. So we turn it on, and then we set the flame on property to be true. Flame on equals true. So we're recording. And this kind of thing is called a flag. We're basically turning a flag on or off. And it's like you're raising a flag or not, essentially. But it is basically like a way of us determining, okay, if it's on, turn it off. If it's off, turn it on. And then we can flip-flop really nicely between the two. The other thing we're going to have to do, if we do it this way, and let's leave this one up for now. The other thing we have to do is we have this play sound. And at the moment, we just are playing the sound, and then we're ignoring the reference to the sound, aren't we? The reference is coming back, but there's no way of capturing that at the moment. So we could do something where we capture the sound that is being played here. Now, if we did the same method we did before, local sound ref equals that. So now we play the sound, and a reference to the playing sound gets stored in our variable here, which means we can turn it off, because that's what you need. You need a reference to the playing sound to be able to turn it off. But the next time this function runs, because this is a local variable, we've used this keyword local here, this sound reference, we won't know what that is the next time this function runs. And this leads me to a really important point called variable scope. The scope of a variable, basically variables like this with local in front of them exist, and they know what they are in memory until the next end. When you hit that end, different languages do different things, but usually it might mean this gets garbage collected, which means that the sound will carry on playing, but the reference to that sound stored in here is wiped. And definitely that will happen when we hit the end of this function. Because there's no point in hanging on to references of things. As the game keeps playing and we're making all this stuff, if we keep storing references to things, we're actually taking up memory. And the more memory we take up, the less memory, by storing references to things, the less memory there is for the new stuff that's being made and generated, or the new things that are being thrown around. So we have to think carefully whether we need to store a reference to something. And if we do, then we can use a local variable, so it gets nicely cleaned up at the end of the function. If we need to store that reference beyond the end of the function, i.e., we need to be able to turn this sound off the next time the function runs, we have to use a slightly different way of storing that variable, we have to put it as a property. We have to use a property of this script rather than using a local variable like this. I could make a property up here, but another way of doing that I quite like is to do self.fire sound ref. So it's a reference to the fire sound which is playing. And now it's stored in this. And because I've used self dot here and then the name of our property, a new property that didn't exist before, that will get created thanks to Lua and Crayta. This sound gets played. The reference to that playing sound gets thrown to the other side of this equals and gets plopped in this. And because this fire sound ref has been added to this self thing here by using this dot, essentially means we've got a property on our script that we can use in the future. And we can use it next time in here. Until this line of code runs, self.fireSound ref will give us nil. There's nothing in there. So it doesn't necessarily throw errors unless we try and do something with that. But if we were to print out, it would just give us nil because it doesn't know what it is. Hopefully that makes sense. So now that long-winded explanation means to turn the flame off in this part of the code, we do these two lines of code here and change that to false. So visible, light visible is false. Flame effect active is false. We need to also stop the sound. Self get entity stop sound. Sound handle was self.fire sound ref. So if the flame is on, then we need to turn it off. Make the light invisible. Stop playing the flame effect. Don't just make it invisible. Stop playing it using the active property. Stop the sound, and finally self.properties.flame on. Is the flame on anymore? No. So set that to false, and that means that we're there. So it will say if this is true, run this bit of code and then get to the end. If this is false, run this bit of code and then get to the end. So now rather than turn on in our event, we will just use toggle. And that's much better because now we should be able to turn this on and off rather than just being able to turn it on. Let's go and have a try. Sound's playing, so that's cool. Light effect and interact again. Off, on, off. Hey, and that's where your question led us. Your question was, should I do 2 functions or 1 function? Well, here's a way of doing it with 1 function, using the conditionals we looked at last time and turning a light on and off. Great question. Another thing we could do before we continue is this boolean here for this light. Remember we had this flame on and it's selectable in the editor. What would be really good is we check that boolean during the init, and if it should be on, we make sure that our light is on, and if it should be off, we make sure our light is off. So this is the next level on is actually having 3 functions rather than 1 or 2 functions. Let's have 3 functions. Turn on, turn off. So let's replace our turn on function with this chunk of code. Put that there. Let's put this lot in our turn off function. And let's just sort the indenting out. And now self turn off here and self turn on here. So now we've got 3 functions. We can either turn it on, turn it off, or toggle between the 2. And we hook up our toggle to the onInteract function, but that will just, if the flame is on, then turn the flame off, otherwise turn it on, and it will just run these functions. But we can also check when the game is initialized. That's what this init means. Init is called automatically by Crayta when the game starts, or whenever this thing comes into being in our game. Whenever this tiki torch arrives at the scene. And so in the init function, we need to go if self.properties. We essentially just need to run this exact condition, but on the init function, and the opposite. So if we've set our flame on property to be true, then make sure that that light is on because we said we wanted it on. Otherwise, turn it off. And what that will do is just make sure that if we've accidentally, I don't know, we've turned on the effect, we don't have the actual light on, but we've just said, we've just caught ourselves essentially. We've just said, oh yeah, no, I want the light to be on, and you might have only just pressed active on this thing, or the sound's not playing. It just means that we can use this checkbox to make sure that it's either on or off as we like at the beginning of the game. And we've got that toggle function so we can turn it on or off ourselves. So there we go. So we've got a light we can turn on or off in the editor, and we can turn it on or off by interacting with it. Great question. When writing code in Crayta, in which case do I write a dot and when a colon? Like in your script, self.properties versus self.getEntity. Great question. I'm glad you asked that one. So this is something we discussed in maybe a couple of weeks ago, but I keep forgetting to include that in my recap. So I'm glad you've jogged me there. When it's a dot, it's something that this script has reference to. So here, the script self has reference to the properties, which has reference to the light, which has reference to a property called visible. So the dot is almost like a owns a thing. Self owns properties which own light, which the light owns a property called visible. The colons are whenever we want to do something. So we use those for functions. Now, getEntity, you might be thinking, why is it not self.entity? Because the script doesn't know what entity it is connected to. The script has to ask Crayta what entity it's connected to. And it does this by almost like asking itself. Script is a type of thing in Crayta, and we can go and have a look at all of the possible things we can do with the script type of thing here. So these are all functions you can call on the script. So self : get properties, self : revert client property, self : schedule, which we looked at last week, cancel schedules. And so all of these things in the API would be self : and then those things. And actually that works with any reference to any other script. So if I had a reference to another script in one script, I could, tell it to run functions by doing that. We also saw we can do self : turn off, which will run this function that we wrote ourselves. So we can use the colon to ask the script to run specific functions. And there are some properties, like the entity, which the script doesn't always have immediate access to. So what it needs to do is run a function to go and get whatever that thing is. There's loads of reasons for that. Another good reason to do it that way is you don't necessarily want to be able to do self.entity equals this other thing, and then where is your script attached to, what's going on, you could end up in a mess. So it kind of, by doing getEntity like this, it kind of forces you to work with Crayta and make sure that it's like not going to turn into a complete spaghetti code and keep working. So hopefully that makes sense. Let me know if that was clear or if that's just made things a lot worse, which is entirely possible given I said, oh, these are things. So Zion's right. Colons used for functions, dots are used for non-functions, but where it gets a bit tricky is where you are running functions which are giving you back code, variables or references to things like get entity, for example. So hopefully that's useful. Cool. I'm glad that's helped. Okay, so we've got a light. We can turn it on or off. Brilliant. That is, and that's it for this week. No, not really. We've got some more stuff to do. Okay, cool. So let's be bold and let's take our light that we've got here and turn that into a template. I feel that this is a reasonably good thing to have as a template, is a light with all of this extra turn on or offable stuff. The other thing I was thinking we could do would be to run a one-shot sound of something getting lit. But for now, we'll just leave it as that. So template, what we're going to do is make this light into a template, and then we'll chuck it some other places in our game world. Template, create new template, and this is going to be our tiki torch. Click OK. So now this thing is a template. What's a template? Well, a template, we can go to the section of our library with this like hierarchy here and click on templates. And templates are essentially an entity that we've had in our game world, and we can store that entity in our library and then replicate it, add duplicates of that to our game. So here we go. If I click on Tiki Torch, which is in my templates here, I can now add it to my game. So I might put one there. I might put another one, maybe one either side of the plinth. Try and center that. And then maybe we could even have some here. Let me just copy paste that, and then grab both of those. And let's just stick those out from the wall a little bit. I'm using shift to, what's not helpful is not being able to see. Yeah, something like that. There you go. Yeah, so add some of those to our game. I might start with these two on. I think that's a good idea. So we can see where we're going. We're leading our player to the right place, and the player can turn on the other torches as they go. So there we go. We've got a light down there. That looks all right. We can turn this one on, this one. And by making these little interactive elements in our game, it really kind of brings it alive, I think. Yeah, that's looking good. Lighting does so much, right, to the game world. It just makes it feel so much more alive. One thing I've noticed is that the sound, because the sound is layering up on top of itself, it's getting quite loud because we've got lots of little candle sounds. So there's a couple of things we could do to fix that. We could either just have one of them have a candle sound. We could add, or we could reduce the volume of that sound. Actually, I'm not sure we could do that bit. I don't know. But yeah, there's the sound of candles. I feel like something else this game world needs is a little bit more atmosphere, so I might look at doing that. But let's just check that we've not broken everything else. Okay, cool. Yeah. Oh, that's really a really good comment. Daniti, is templates. You can make packages and then you can put templates in them. And that means that the person that installs your package can just take that. So if I wanted to, I could make a sweet lighting package, which has got loads of different types of light in it, like tiki torches, braziers, sconces, you know, chandeliers, whatever. And then I could package all of those different types of light up and make an awesome lighting package, put that on the community, and then everyone's got access to those lights, and all they've got to do is they install it, go into their templates, and then click on, oh, I want a tiki torch, and then place it all over their game world. Great question, great comment there. Thank you very much for that. Right, so I'm gonna probably just take out the sound for now because I feel like it's quite loud. I'm just gonna take that out, and instead I'm just gonna let's add some night insects. Jungle insects, and we'll turn off 3D in ranges so that it's everywhere, and we'll just drop that volume a little bit. Sometimes it's quite good to do multiple things. So we'll have another, we'll have some cicadas. Oh, don't want to drop the pitch. Jungle. Yeah. So, a couple of sounds. Yeah, it kind of brings it alive and it makes it feel more night-timey. It's not really scripting, but it adds a lot. So I wanted to do that. Let's go here, click that. Okay, cool. So what's next? What was the next thing we were going to do? Well, what I wanted to look at next was, okay, we've got this sick entrance to our tomb here. Let's say sick. I mean, like, awesome entrance to our tomb. What I'd love to do is hit a trigger when you hit, I don't know, this point. And woomph, some fires start up in here. And it's like, whoa. And maybe even some music plays. So that's what I thought we could do next. But multiple fires at once. And we're going to have a look at iteration and array containers in order to do that, because I think that's a really good opportunity to look at that thing. It's not the only way to do this. A good way to do that would be to have like a trigger, an event, and then it could just talk to all of the things at once. But I'll show you why we're going to do it with an array and iteration. Is because it'd be quite cool to stagger them turning on. And yeah, we can do that using schedules, arrays, containers. So we already know what schedules are like and what we can do with those. And the next thing we're going to look at is arrays and for loops. Cool. Right. So let's go in here. Let's add a tiki torch here, just here. But instead of a tiki torch, I'm going to break the template link. So it's not the template anymore. It's its own thing. It's still got the script. It's still got the children and all of that stuff. But this I'm going to turn into more like a fire, like a brazier or something. In fact, I'm going to call it brazier. And I'm going to change the mesh to be a brazier. This. And let's move it in a little bit. And let's change this fire candle. That's not what we want anymore. We want a fire. This can be just a small fire. Let's make it active so we can see what that's like. And let's bring it down. And notice the light is still attached, so that's super handy. Fire magical blue? Nah. Fire small, fire large. I mean, that would be cool as well. We could do something even better like that. And then instead of a brazier, we could have the pan. Gold pan jumbo. Yeah. That's probably better. Just quickly gonna do some of this. Make a light here out of a couple of things. A London house coffee table is a classic. There. So now we have a massive light. I think that's gonna have the desired effect that we want. So they'll come through the door and whoomph. I mean, it's pretty imposing. I wouldn't like to be near it. I wonder if there's other fire. Nothing with the same significance. Okay, let's drop that. Yeah. Might feel a bit dodgy having it so close to the player, so let's just move it all the way over there. Okay, so we have this type of fire now, and so technically this should work. Let's make a copy of it for now and just plop it over here. And so they should be on by default. Let's go down, turn the, open the door. You know what would help is having some light. Okay, we've got these massive fires. Cool. It's lacking a lot of impact, and that's because it doesn't feel like you can really see them. It also doesn't feel like we're doing it. It's like we've just sort of arrived here. So let's grab these. Firstly, move them up a bit. And secondly, they need some sound. But we're going to use the old script for the sound. And now we have two. Let's make it so we have more of these. I quite like them, so I'm going to delete one. I'm going to turn this into a template, and this one's going to be called Brazier. Click OK. Let's grab that template just like we did before. Let's add it over here. Let's not just turn the coffee table into a template. Let's turn this one into a template. Click OK. And that's better. Let's now add the brazier over here. Well, it's part of it. It's the cool thing is it's a template, right? So that's the main thing, that this is a template, and I'm going to copy and paste because I've already got my positioning kind of sorted out. Z-axis positioning sorted. Let's copy and paste. Let's get 4 of them. Let's make loads. Let's have 1, 2, 3, 4. Let's paste another 2. And let's have those at the entrance. So that one and that one, you can be the side of that. This one and this one. You can be all the way back here. Probably should be in front of these dudes, but that's okay. I'll just leave it like that. And you guys can be at the front. Cool, let's try that. I seen a dragon statue breathing flame in one of the games. Have to ask them about that. It'd be kind of similar to what we're making at the moment, except you'd have your fire effect and put it on your dragon. So what I want to do is you get to this point here and it go jung, 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 music. Like a very cinematic moment in the game where you walk through the door. So let's do that. Let's make that a thing. It's possible. So firstly, when I'm walking and I'm not hitting an object or interacting with anything, the way that we're going to fire an event by walking is by using triggers. And if I go to my primitives, I can find this trigger, place that in my game world. It's an invisible area. It's an invisible volume in your game world. And so what that means is the player won't be able to see it, but the effects of it we can demonstrate. We can add functionality to it. So let's make it big enough that they're not going to miss it, so that they will have to walk into it. That's good. We might reposition it depending on what works and what doesn't. And then when they enter the trigger, we want to turn on this one, then these two, then these two. So we want to stagger these. So we're going to write ourselves a little loop that actually, rather than staggering them, I'm going to do 1, 2, 3, 4, 5, 6. Yeah, I'll do it in an order like that. So what do we need to do here? We need to kind of orchestrate this magnificent event. And so for this scenario, rather than attaching these to the braziers, which have that light script attached to them, don't they? So rather than attaching a thing to each one that tells it what time to turn on, another approach could be with our trigger to add a script that knows about all of these braziers and turns them all on one by one. So we'll do that. It's not going to be the most perfect way to do this, but it will talk about the concept that what we're after, which is arrays and for loops. So let's add a script to the trigger. Entity, I've got my trigger selected, entity add script, new script, and this is going to be called cinematic lighting script. Okay. Oh, Zion was saying they wanted someone to create a dragon package. That would be cool. You could sort of use some of the stuff we've looked at today to do that. But yeah, if anyone fancies it, that's an opportunity. Okay, so we've got our cinematic lighting script. So firstly, when we enter it, we're going to turn on the light. So let's get a reference to one of the lights. Name equals brazier. Type is an entity. So let's get a reference to that light. So let's use this one. This is where my busy world tree is not doing me any favors. Okay. This is going to be tricky. Okay, you guys, these braziers, all of them. Let's group those. Oh, I can't group them. Yep, nope, can't do that. Okay, we're going to call this brazier trigger, so it's near the braziers. This is a really hacky way to do world tree organization, but it works. So I'll do it for now. So we just need a reference to that first brazier. There you go. So now we have that. Let's turn it on. Let's create a function. This is going to be called turn on. Just like our lighting function, we're using a convention now called turn on. Another convention that I probably should use is activate, because that actually plays in nicely to like the names of the animations and things like that in Crayta. So what we want to do is when we walk into the trigger, we run this activate function. This activate function should go send self.properties.brazier. We actually want to call turn on the light script, which is attached to the brazier. Okay, so we've got this light script attached to this entity. That light script we wrote, and we wrote it so that we could we had this function called turn on, and we had this other function called turn off, and we can even toggle and stuff. And what we want to do is, using this method, we're going to grab a reference to that entity, and we want to run this function on this entity. And there's a few ways of doing that, but one of my current favorites is send to scripts, and then the name of the function we want to run in quote marks, turn on, end quote, end brackets. So we're running a function on this entity called send to scripts, and that will run the turn on function on any script that's attached to the entity we're referencing. So it's a really handy thing. It's a Crayta call in here. So if we look at entity, you have this send to scripts here, and it will call a function on any entity, which means that unfortunately this brazier trigger is now tightly coupled to the braziers because it needs to have this event on it, and that's not necessarily ideal. What would be nicer would be to have like the ability to just turn them all on or whatever, but because we want to do a special thing where we're going to stagger them turning on, for now, and to talk about the idea of for loops and containers, we're going to use this center scripts functionality here. So let's have a go at that. So we've got that activate function. Let's make sure it runs when we enter the trigger. On trigger enter. So I've selected my trigger, on trigger enter, new binding, drag the trigger onto there. It'll automatically select this script that we were writing, and we want the activate function. Let's try that out. I'm going to press F5. And let's go into our door. Ah, they're already on, aren't they? Yeah. So I need to turn them all off to start with. Let's turn them all off. So, flame on. Good job we set up this boolean down here. Cool. Turn them all off. So now when I enter the trigger, hey, one of them comes alive. Okay. Interesting that it's that middle one. We probably will order these a bit more appropriately in a minute. So now that works. So we walk into this this trigger, and it feels like some sort of a ethereal thing is going on where the light just turned on. Ooh, spooky. Let's put the sound back in. No, let's not. Should we put the sound back in? I don't know. Might do the music and stuff instead. Now let's put the sound back in. No, let's not. So indecisive. Okay, so we want to turn that on. So right, so now how do we turn on lots of them? I could do the event on trigger enter and then hook them all up to the turn on function in the light script, which is attached to each one. Or I can do it this way, which is a little bit more tightly coupled, which isn't necessarily what we want, but we can do this cool thing now where we have in our property here, container equals quote marks array like this. And I want to show you what happens. So selecting the brazier trigger. So watch what happens with the brazier property. If I save this, it's turned into a group. It's turned into an array. An array is a group of entities. Notice that they have to all be the same type. So if I wanted to, I could put is equals light, like I had here, is equals light, and they would only be an array of lights. If I put sound asset instead of entity, they would be an array of sound assets. And what's really cool is we can now have lots of them, and they are ordered. So I can refer to specific ones in the order. Notice this has got a 1 next to it. So actually we don't want this one here at position 1. We want the closest one to us at position 1, which is brazier 5. So let's get rid of that. Let's put brazier 5 there. Now to add more entities, I can either drag and drop them onto that, so it just adds them below, or I can, to remove one, I can right click and do delete element, or I can click the plus and then drag the entity onto there. So let's keep going. Let's add some more. Where are you? You're number 0. So let's put you on next. Here, number 1, here, number 2. So then it's 3, and then it's 2. So I've dragged these on in the order that I want them to light. And notice they're all over the place with the numbers. But these numbers, 1, 2, 3, 4, 5, 6 down here, they're how I can now reference these individually as part of the group. Let me show you what I mean. So rather than doing just this is still valuable code. We still need to keep it, but it won't work at the moment. So I'm going to copy it, comment it out. Let's loop through this group. And so this array of entities. So we have an array of entities now, which means we have multiple entities in our game that are referred to in this script under just one name. I might even change that to braziers. That'll delete the array if I change that. So we'll have singular, and just know that brazier now has 6 entities within that one term. So how do we use this? We could do things individually. So if I wanted to, I could keep this line of code, and to refer to the one and to turn on brazier 5, this one here, I now put next to this brazier identifier here, I put open square bracket, and then I choose one of the numbers on that list, 1, 2, 3, 4, 5, or 6. I'll put number 1 in there, and then close square bracket, and that refers to the brazier at position 1. The brazier at position 2, I put a 2 in there. I put a 3 in there for brazier at position 3, and so on. So now I can refer to these guys, or these braziers, using square brackets. Let's test that. F5, run down here, and let's open the switch. Let's press the pedestal, and when I enter the trigger, oh, it turns on that one. Hey! So, that's cool. The next thing to do then is to think about how are we going to turn all of them on at once. Hey Unaif, nice to see you. And so how are we gonna turn them all on at once? We are going to use something called a for loop. So if I go to, remember this is fun, isn't it? If I go to this this flowchart here, what we're going to do is we're going to walk. Let's zoom in a little bit and go over here. Walk into trigger. That's our start. Like this. And then we're going to write a little flowchart out so that we know what we're doing. Walk into trigger, arrow. Turn on brazier 1 in a process, so in our little box, and then this is what we would do normally. We could write it out line by line. Turn on brazier 2, and so on. You know, we can keep going, arrow, dot, dot, dot. So we could keep writing all of these out, but then what happens if in the next scene in our game you enter an even bigger temple and it's got 100 braziers in it? Do you want to write out 100 lines of code? Not really, especially if each one of those lines of code then needs to be maintained, possibly has errors, and also if you wanted to make a change, it's going to take you a while. You know, if you changed the name of the function, for example, you'd have to go through and change all of them. So rather than doing it this way, line by line, changing all of these things, we can actually we can create a variable. So we can create an index. We can create a variable index, and we start it at 1. So that's the first step. Then we can do turn on brazier, use our square brackets and put that variable in there. So to start with, this will turn on brazier, the brazier that's in that array at position 1. And then, rather than writing out turn on brazier index +1 or anything like that, we can go index equals index +1, like this, and then go like this, and go back to this point, go back here, and then do this, and then increment by 1 again. So index starts at 1. We turn on the brazier at position 1 in the array. Then we increase index. So index is now 2. We go back to this point and we turn on the brazier at position 2 in the array. Then we increment our index. So index is now 3. We go back to this point and we turn on the brazier at position 3 in the array. And we keep going. And it would technically go on forever, except what we're going to do is use our marquee tool to grab this stuff, take that, paste it down here, and in between there and there, we're going to run a simple function that is index less than brazier length, like the number of, let's delete that, number of items in brazier, which is the name of the array, remember. It's awkward that I've called it the same thing as one of the properties. Is index less than the number of items in the brazier? Actually, that should be a pointy one because it's a decision, right? Okay, and then that's it, got it. If it is, so yes, we go over here, and if not, we go down here. Oh, I've done that. That's a part of that. Come here. Take that out of there, paste it. So we put that there. This will be our yes side. If it's less than, do this stuff. And if it's not, we do this stuff. So yes. That's a yes. And otherwise, no. End here. And so what we're actually doing now is this. Huzzah, there's our first loop. Awfully done because I ran out of canvas. But essentially, let's run through it together. This is our flowchart. Walk into the trigger. At that point, we declare some index is 1. We basically create a variable and we put the number 1 in that variable. Then we run a conditional. We say, is the index or the number that is in index less than the number of items that is in our brazier array? If it is, turn on the brazier at whatever the index is, so position 1 to start with, and then increment our index by 1. So now index is 2. So then we go back to this point. Is 2, remember now index is 2, is 2 less than the number of items in our brazier? Well, brazier had 6 items in it. Is 2 less than 6? Yes, 2 is less than 6. So now we turn on the brazier at position 2. We increment the index, so index is now 3. We go back to our conditional. Is 3 less than 6? Is index less than the number of items in the brazier? Is 3 less than 6? Yes, it is. Turn on brazier at position 3. Increment our index by 1. Go back to this point. Index is now 4. 3 plus 1 is 4. So now is 4 less than 6? Yes. Turn on brazier at position 4. Increment our index to 5. Is 5 less than 6? Yes, it is. Turn on the brazier at that point at position 5. Increment our index to 6. Is index 6 less than number of items in the brazier? Technically, 6 is not less than 6. So we won't get to the brazier at the 6th position. So it needs to be less than or equal to. Is 6 less than or equal to 6? Yes, it is. It is equal to. So it's less than or equal to. Turn on the brazier at position 6. Increment our index to 7. Is 7 less than or equal to 6? No. So then we go out here and we don't try and turn on anymore. We just end our function. So I know this is awful, an awful diagram. I'm so sorry. But the principle is there. We're creating a loop. Now, how do we put that loop into here? Well, fortunately, programming languages have ways of iterating. There's two main ways. There's a for loop usually, and a for loop is great if you have a finite order, a finite number of things. It's perfect for handling arrays because we know that there is going to be a number of things in that array. We also have while loops, and while loops will keep doing something until a condition is false. So we'll keep that a while loop is like run around the house until dinner is ready. Whereas a for loop is like run around the house 5 times. Hopefully that makes sense. So in this situation, we're going to use a for loop. For, and we can actually create our index in our for loop. We can do index equals 1. So that was this part here. Index equals 1. For index equals 1, comma, hash, the number of things in our brazier. Remember, we now need to know how many items are in our array called brazier. So hash self.properties.brazier, that hash basically counts how many things are in that brazier. And in Lua, this is us saying index start at 1 and check it against the number of things in brazier every loop. And we have do, which is another keyword, which just ends the sort of the definition of our for loop. Start at 1, go up to the number of things, up to or equal, while it's less than or equal to, or keep going, incrementing until it reaches this number. Do, and let's put our end here so that we're not got any errors. And in here, we essentially want to use this line of code, cut, Control X, paste that in here and change this 1. So rather than just turning that first one on every time, let us use the variable index to turn on a light every time. So what it's going to do is essentially this flowchart, but it's doing it in this little for loop here. So we're looping through every item in the array and we're sending the turn on event to each item. So we're running a function on each item. Let's try running that. Using F5, we're going to test it out. We're going to walk down here. We're going to flick our lever. I'm going to walk back up here, switch the pedestal. No lights. And let's walk into the trigger. Haha! It did it so quickly, it's instant, right? So all 6 turn on at once. And you can't see that loop running, but just know that behind the scenes, that loop is looping through each item in the array. And now it doesn't matter how many items are in my brazier array. I could have 100 in there and it would turn them all on at once. The next step, this is getting pretty full on. The next step is to put this in a schedule and then wait between each item. And we can do that, can't we? Because we did scheduling last time. And the light was made, yeah. So we did self-schedule, and then you can use the wait function. You can't use wait unless you're in a schedule because you need to be off the main thread, right? So we said code runs over here on the main thread, and at some points we might need to break out if we are ever going to need to wait for something. And in that breakout code, we can kind of manage the amount of time between lines of code that we write. So we're going to do self-schedule here. Open bracket function, open close bracket, and then let's end it with end close bracket here. So that line of code starts this separate thread, this separate thing, this separate routine, or whatever you want to call it. So it's now not running in the same, it's no longer syncing up to the main one that carries on running. And at the moment, that will just behave exactly how what we had before behaves. This is exactly the same because this is running immediately. But what we are going to do is in our little for loop, we're going to do wait, and we can wait maybe 0.3 is sometimes quite a nice number. I generally go in thirds of a second. I think that's quite nice. Wait 0.3 seconds. I got ahead of myself there. So run this, start up our index, and run this for loop until our index is equal to the number of things in the array. That we are happy with. We've also used this self-schedule so that we can use wait. The wait command will wait this amount of seconds before executing the next line of code or continuing on. We can only use wait in a schedule, which is why we have put this schedule here. So we've got for this amount of things, firstly wait for each one and then turn it on. So wait 0.3 seconds, turn our first one on. Wait 0.3 seconds, turn our second one on. Wait 0.3 seconds, turn our third one on. I might actually put the wait after, no, wait 0.3 seconds, turn our fourth one on, and so on. So let's see what that looks like in our game. Locked. Haha, it's looking pretty cool. It's looking cool. Unif says, schedules are so useful and I use them so much that I have a macro to write an empty one. Good for you, Unif. They are awesome. Timing stuff is, and it adds so much. It even like a little bit of timing delay, or it just adds so much to the game, because it, you know, it makes it feel like it's not necessarily been, it's not like a computer that's controlling the environment. It feels like you have done something, the player has done something, and the world is responding after a short amount of time, whether that's thinking about it, whether it's a trap mechanism whirring, whether it's animals reacting, whatever that is. So scheduling and timing is really helpful and really important. Cool. So it seemed all right. I think we need some sound in there. Is there any flamethrower? Yeah. Oh, look, we can do flamethrower fire multi. So let's edit our brazier. When it lights, I want the sound of a flamethrower. I'm going to put multi in there because that will choose one of these other ones. So it'll be different for each one. Let's put the sound back in here. And let's hook up some more things as well. Let's also put some music in the game world. I feel like there's a... I think it's that. But I think that's possibly needs to come from the Switch. So I'm going to, yeah. I'm going to do the skull reveal. I'm going to put it on the pedestal. I'm going to turn off 3D and ranges so that it is the whole thing. I'm going to add a play sound script to it. Yeah, I'll quickly add a play sound, add script, new script, play sound script. Oh no, shouldn't do that. Should I do that? Yeah. I want it decoupled. So it's not active by default. And all we're going to do is play, write a function called play, and we're going to do, we're going to just make it act itself, get entity dot active equals true. Now, because it's a sound, it's not a looping sound, that means that it will play once and then that will be the end of it. So we'll just have this single play function so that when you press this and our temple door opens the door, the open door needs to check that it's locked or not. If it's not locked, do this stuff. I want it there now. Delete. Let's put it as a property in here. Reveal music, we'll call it. Reveal music. You could do some adjustments on the loop. Oh, could it be adjusted to make 1 and 2 at the same time than 3 and 4? Yeah, I'll do that in a sec. That's a great idea. Let's do that. Just finish this little bit of additional stuff. Play sound. Rather than just playing the sound, which will add the sound into the game world, but it'll be 3D, so you'll hear the direction of the sound. I'm going to play it 2D, which means that it will come over both headphones at once. It's not going to be 3D, but then music, unless it's coming from a particular area in your game world, you can make the music kind of part of the play experience without necessarily being completely simulated in the game world, if you know what I mean. So 2D is a good way to do that, and this is going to be self.properties.reveal music, because I feel like it needs some reveal music at this point. I've added that. I haven't added that to my switch pedestal, but in my door script, that's in my door script. Let's put that reveal music in skull reveal. Yeah. Cool. So that gets called when the doors have opened. I feel like it needed that. The light script now plays the fire sound when I do that. I just feel like it needed some serious leveling up in the sound area to kind of deal with what's going on here. It's quite nice because it's really quiet and chilled, and then it's so much fun. Feels like I'm on a film set, except now every time I enter the trigger, it's playing those sounds. Just slightly terrifying. It could be cool to have that. Maybe the last thing to do then would be to set whether this is active or not. And if it's not, if self.active is nil, then self.active is true. Put that there. Just a quick and dirty flag there. Let's see whether that works. So turn these little lights on as we go. Ooh, there. Turn you on. Turn you on, and so on. Go down here. Cool. So that means that, yeah, now when I re-enter that trigger, it doesn't play the sounds again. So it's not lost the impact of that moment. I think that's pretty much everything I wanted to cover today. Oh, there was a question. That was a really good question. Yeah, I can make this level remixable, no problem. Yeah, I'll publish it and make it remixable while I'm on, or while I'm live here, so that you can check it out. Definitely will do that. Let's have a look at that question that was, can we make it so that lights go on 1 and 2 and then 3 and 4? Okay, so this is probably a little bit more technical, but let's think about the problem. It goes back to the old, I don't know if you ever did this in school with maths, but there was like a branch of maths that looks at sequences that goes like n plus 1, n plus 2, that kind of thing. That branch of maths, what's that called? That is, yeah, let me know what that's called. It's escaped me for a second. Nope, can't remember the name of it. Anyway, that branch of maths is really helpful when you're dealing with loops. And so what we need is almost like a table like this. 1, 2, 3, 4, 5, 6. One thing you could do quite simply is you could use an if statement, and you could say, if this number is 1, then do this. If this number is 3, then do this. And that is possible, But then we run into the problem of what happens when we've got 100 lights we want to turn on and they're in groups of 5 and that kind of thing. So one other thing we could do is if what we need is every other one, right? And so we could use something like modulus, which is a mathematical function that divides one number by another and then returns the remainder. So that can be really, really helpful for determining if, you know, this is the third one in the list, the fifth one in the list, and so on. I'll see if I can remember how to do it off the top of my head. Math.mod, fmod. This looks like it's part of Lua. X and Y. I need to math.fmod Lua. I need to read up a little bit on what this is. This is where we dip into the Lua documentation rather than the Crayta stuff. Returns the remainder of the division of X, which is the first number, by Y, that rounds the quotient towards 0. What's mod f then? Mod f returns two numbers, the integral. Oh, I don't want that. I don't want integral. Was it fmod? Yeah, math.fmod. Okay, so it will be a whole number of x divided by y. So index divided by 2, and it will return the remainder. So if index is 1, 1 divided by 2 is 0, remainder 1. If index is 2, 2 divided by 2 is 0, remainder 1. So we need to, 2 divided by 2, which is 1, remainder 0. So we need to check the remainder. Remainder is that, right? And then it's going to be either 0 or 1. So we can do, and if it's 1, okay, just bear with me a second. So we've got the remainder. In remainder, well, the first one, the remainder will be 1. On the second one, the remainder will be 0. So we'll do weight of 0.3 times 1 minus the remainder. So if the remainder is 0, if the remainder is 1, which it will be for the first one, remainder 1, 1 minus 1 is 0, don't weight. So don't weight between Brazier 1 and Brazier 2. When we do Brazier 2, 2 divided by 2 is 0, so our remainder is 0. 1 minus 0 is 1, so wait 0.3 seconds. When index is 3, 3 divided by 2 is 1, remainder 1, so the remainder here will be 1. 1 minus 1 is 0, so 0.3 times 0 is 0, which means 0 waiting. So let's try that. Should group it in, group it by into. Okay, that's locked. Don't forget that there's still a puzzle you have to solve before every time you view how your programming skills are. There you go. It's much better. Great suggestion. I love it. This is fun. Any other suggestions would be deeply welcomed. It's 6 o'clock, so unfortunately this is the end of the stream. I am going to publish this game, which is called Jungle Bungle 2. Let's not call it Jungle Bungle 2. Let's call it, what's the name of this stream? Introduction to Scripting? Oh, Scripting for Beginners. I'm going to call it that. The jungle exploration game Andy made on his Scripting for Beginners stream series. Continue. Cover image. I think that's a suitable cover image. I'll leave that as that is. We will do images. I'm not going to do them right now. Is there a tutorial tag? Yeah, there you go. Tutorial. Let's just put that there. Let me know if you have any suggestions for further streams. Don't forget to like and subscribe to our YouTube and our Twitch. If you're at all interested in more things like this, let me know in the comments. Comment below on anything else you want me to cover in part of my Scripting for Beginners series. If there's any questions that you have, any problems you run into, especially problems you run into if you're following me exactly, because then we could take a look at it and I can make sure that if someone else hits that problem, they might check out the comments and there's the solution below. There you go, Scripting for Beginners. I've published that game, so that should now be playable. You can go and do the very, very basic thing of entering the temple. Let's also take that and sharing. Allow remixing. Oh, yes, of course. Allow remixing. Let's just check that that's now an accessible game to remix. Go in here. Let's search for scripting. There it is. Cool. So you can go away and you can investigate that. What I will do is work on my comments and tooltips, because there aren't currently any of that stuff to help you out when you're taking another look at it. Yeah, so I will do that stuff. I'm going to leave in the crazy maths if you want to explore that. If you wanted to do groups of 3, then you would might be a bit more complicated than this, because you put in 3 and then the remainder will be either 1 or 2, or 0, 1 or 2. And so the maths gets a little bit more complicated when you do any more than 2, because you start needing to divide things and floor them to iron out, to make it into groups. Basically, we're lucky because in this situation, 0, it's only ever going to be 0 and 1. So we're lucky here, but worth bearing that in mind. Cool. What else we got? Questions, schedules. That game will be added to my and Tay's faves now when we go into the game. Cool. Yeah. Get stuck in. Have a look. Remix it if you fancy it, and this is interesting to you. Add some story. That has all of the mechanics down here for an obby. So technically all of that code is already in here, and the obstacles are down the bottom here. So that's something that I'm going to look at exploring in more depth next week. But if you want to, as some homework, you could go and play around with the level and just see if you can make a bit of an obstacle course. That is totally something you can muck around with. Or take the level and try and turn it into a space level or something else using the same sort of mechanics. That'll be fun too. Don't forget to like and subscribe. It's been great. Thanks for being so cool and welcoming and helpful in the chat and asking some fantastic questions today. I'm so pleased. This has been my stream this week. I'm Andy. Lovely to see you all, and I look forward to seeing you next week, where I'll be carrying on. Take care, everyone. Bye bye.